As a reminder, why we break up the S section here, why we don't just say 2s8 or whatever, why we go from 2s2 to 2p is because these electrons here have a different shape. Their levels have a different shape. Once we get to the p level, it's still part of energy level 2. It's just a different subsection that is shaped differently than the s level. So all of these are found on the s level, and all of these are found on the p level. Good? So we have 1s1, 1s2, 2s1, 2s2, 2p1, 2p2. So that's how we end up with this for carbon. And we write everything just like you had to draw the whole Bohr model. We have to write out everything that came before it, just like that. All right, let's do another example. What's another example I have down that we should do? Let's try nitrogen. Okay, nitrogen is right here. It's number 7, so we have to end up with a total of 7 electrons. We know nitrogen is in our p section. 1, 2, 3. So it's in column 3 of our p section. So we know we're going to end up with 2p3. What comes before 2p3 though? You can always reference this. You know it's going to end up in 2p3. So what comes before 2p3? So I mean, we can just go backwards. You know, because it's in the p section, it's in period. It's in the p section, it's in period 2, and it's 1, 2, 3. You know it's going to end. You know it's going to end in 2p3. That's how it's going to end. You know that. You already know the ending. But what came before 2p? Reference this. If we're on 2p, that means we already filled up 2s, and we know 2s can hold up to 2, and it's got to be full before we could have ever moved on, so 2s2. And then what came before 2s? 1s. So we knew, sorry, this is going to be bad. I didn't give myself enough room. We know we filled up 1s because it would have had to be full before we could move on to 2s. So we end up with 1s2, 2s2, 2p3. So that's the way you can work backwards. If you know it's in the p section, you know it's in period 2, and you know it's element 1, 2, and 3. So you know you're going to end up with 2p3. You just work in reverse using this handout. Got to 2p, meaning we had to fill up 2s and 1s first. If we would have done that in regular order, not going backwards, we see nitrogen's here, so we have to give credence to what came before nitrogen. So we know 1s1, 1s2. Boom, full. We know 2s1, 2s2. Boom, full. Then 2p, we have 2p1, 2p2, 2p3. That's how we could have written that going in regular from the start to finish order, not starting with the end in mind. Okay, we're going to do one that goes into row 3 or period 3, and then I'm going to let you try a few. So let's say we're doing aluminum right here, number 13, aluminum. We know we have to end up with 13 total electrons. So we're going to go forward this time. So aluminum's right here. Again, reference this sheet. We have to fill up our 1s first, then our 2s, and etc., etc. Follow this. So our 1s, 1s1, 1s2. S can only hold 2, so we know that's full. So we always start with hydrogen and work our way down. Across the row, left to right, then down. Across the row, left to right, then down. Across the row, left to right, just like that. So 1s2, we have full. 2s2, or 2s1, 2s2. We know that's full. 2s2. Okay, we know that's full. Then we keep moving over 3p or 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. Look at that, p can hold 6. So our 2p is full. This level right here is full. 2p6. 2p6 is full. So what does that mean? That means we have to move down another row, another period. Now we're in period 3. 3s1, 3s2. Okay. Our 3s is full too. 3s2, because we know 3s can only hold 2 electrons. And then we're over here. This is 3p1, and that's where we end up with aluminum on 3p1, because it's in our third period, third row, and our first of the p elements in our third row. So it's 3p1. And again, the p look like this, whereas the S look like this. That's why we separate those. Let's check our work. We needed 13 total electrons. Do we have 13? 1, 3, 9, 11, 13. So it's right. That's our configuration. 1s2, 2s2, 2p6, 3s2, 3p1. Now, if we had done that in reverse, for those of you that like to work backwards, sometimes I think that's easier. If we looked on our paper, at the beginning, very beginning of the problem, I said, find the electron configuration of aluminum. You look right at aluminum. You see it's in our P section. You see it's in period number 3, row number 3. And you see it's right here in the first position for row 3 in our P section. You knew right away that it would end in 3p1. We get each one of those numbers, 3 from our period, p because it's in our P subshell right here, and then 1 because it's in our first column of our P subshell. So 3p1. You could simply look on here, see that we are on the 3p level. Okay, that's where we end up. We end up on the 3p level, which means everything before this level has to be full. So you could just go in reverse and know that 3s1 or 3s2 had to be full. 2p6 had to be full, and you can follow in here. So we're at 3p1. We knew that our 3s had to be full, our 2p6, it had to be full, our 2s2 had to be full, and our 1s2 had to be full. So if you know where you're ending up, you can use this chart to just work backwards. If you know the how to use this chart and where we're going to end up, we know we end up at 3p. You just go back, 3s2, 2p6, 2s2, 1s2. Boom, you're done. That is how we do our electron configurations. This right here, the 1s2, 2s2, 2p6, 3s2, 3p1, that is the electron configuration of aluminum. Knowing your subshells, S and P, it's absolutely vital that you can do that. And then right here, S, P, D, and F, you see they have different shells, and that is why we have our different subshells. Remember, we're not changing. Each energy level still holds a total of 8 electrons. It's just divided into 2 for the S's and 6 for the P's. Just divided like that. Now I want to do a few practice problems with you. So you're going to write these in your notebook, wherever you've been taking your notes. You're going to write down these practice problems. And then after, oops, didn't mean to erase that. And then after you have done some practice problems, go on and do the sheet you picked up on your way in along with this. Because once you can do that, and then you need to have me check that, once you can do that, then you can go on to the gizmo, which we'll do after. But first you need to make sure that you understand how to write the energy levels all the way through period 3. We're not going to get down into the D's just yet. That'll be the next video. So here we go. Let's do beryllium, Be. Write the electron configuration for beryllium. Pause the video, write that, and then I'm going to restart the video, and then I'll give you the answer. Okay, hopefully you paused the video. Beryllium's located right here. We know it's going to end up with 4 total electrons. So to write that, I'll do it in, we'll go reverse. Now we'll do it regular. So beryllium's number 4. So we'll go 1s1, 1s2, full. 1s is full. So we can go ahead and write that. 1s2, 2. 2s1, and then 2s2. That's where we've arrived at beryllium, at 2s2. 2s2, and we're at beryllium, so we can go ahead and stop. So it's just 1s2, 2s2. That's your answer for beryllium. Don't understand it, make sure you pause and ask me. You don't have to watch this whole video without understanding. Make sure you pause and ask me if you don't understand it. Okay, next example, oxygen, right here. Pause the video, do the example. Okay, oxygen. Hopefully you pause the video. Pause the video and do it. You don't understand it, ask me. Oxygen. We have oxygen. We'll go front ways, or like front ways. We'll go normal direction, 1s1, 1s2. There we go, 1s2. 2s1, 2s2, all full. 2s2, both our s's are full. We see oxygen. We're still in the second period. We're now in the P section, and it's P1, 2, 3, 4. So it's going to be period 2, section P, element number 1, 2, 3, 4. Check our work. We need a total of 8 electrons for oxygen. 8, this number. always has to match all of these numbers added together. So we have 4, 6, 8, victory. That is our electron configuration for oxygen, 1s2, 2s2, 2p4. Now if you wanted to work backwards, you could have looked here. Right off the bat, you could have seen oxygen is in the P section. It's in period 2. It's number 1, 2, 3, 4. So you could have known that it was going to end in 2p4. You know that's how it has to end. And then if you look at your chart, you know you can just work backwards. So you have 2p4. That means coming before 2p4 must be 2s2 and 1s2 because those both have to be full before we could have ever gotten here. So if you work backwards, you see second period, fourth element over, P section ends in 2p4. Know that I have to fill up every preceding energy level before I ever would have gotten there, so I know that it would have been 2s2 and 1s2. You get the same answer, just going in reverse. It's just whatever you prefer, however you prefer to solve it, either going in reverse or just counting all the elements one by one. Either way is fine. We're going to do 2 more examples. F, fluorine. Right here, solve for fluorine. Electron configuration. Okay, fluorine. Counting all the elements, 1s1, 1s2. You know that's full, 1s2. Remember, S can only hold 2. 2s1, 2s2. And then 2p1, 2p3, 2p4, 2p5, 2p6. Sorry, 2p1, 2p2, 2p3, 2p4, 2p5, 2p5. Okay, does that match? We needed a total of 9 electrons. We have 5, plus 2 is 7, plus 2 is 9. 1s2, 2s2, 2p5 is the electron configuration for fluorine. If you work backwards, you realize it's in period 2, element 1, 2, 3, 4, 5, 2p5 is how you end. And then you just look at this. What do I have to fill in before 2p? You'd have to do 2s2 and 1s2. Fill it in, and you'd have your electron configuration for fluorine. Okay, if you already feel like you can go on to the work that you picked up on your way in, then you are more than welcome to, because these are just further examples if you don't quite understand. This is the last one I'm going to do, though, and that's Na. Pause it, do Na. Okay, Na, hopefully you paused it and did it. Seriously, you need to take ownership of what you're doing. Don't just watch the video if you don't understand. Pause, do the work, call me over if you don't get it. Na, I'm going to do it backwards first this time. You know it's in our S sublevel. It's in row 3, or period 3, so you know it's going to end in 3S, and it's going to be 3S1. You know that's how it's going to end. So if you just looked on here, find your 3S. You know every energy level that came before 3S has to be full. Every energy that came before 3S has to be full. So 2p, how many can p hold? 6. So you're going to have 2p6, 2s2, and 1s2. So it would be 2p6, and then 2s2, and 1s2. And that would be our electron configuration for sodium. And that works because you go 1s1, 1s2, 2s1, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6, 3s1. You see why it's 3s1? Period 3, sublevel S. These 2 columns are sublevel S. And then it's number 1. Like if we came over to sulfur, we'd add on, it'd be 3s2. 3s2 because we would have gone 3s1, 3s2, and then it'd be 3p1, 3p2, 3p3, 3p4. See how we just kind of add on to that as we add more? Use this. This is how we have to fill them up in this order. We progress this way. You have to fill up each arrow. Sorry. You have to fill up each arrow working down before you can move on to the next one. Do the practice problems you picked up on your way in. I need to check those before you can move on to the next activity. You're working at your own pace. If you don't get it, rewatch the video, get me, ask a neighbor, but as soon as you finish the practice, let me check it, and then you can move on to our next activity dealing with electron configuration. Alrighty, go ahead and get that work done. Don't understand, you know what to do. Until next time, farewell.